When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. What we're going to do in this video, we're going to cover this HSC exam question, which comes from the acidic environment module, and more specifically the acidic oxides chapter. In a second, I'll read the actual question. Once I read the question, give about 5 seconds to pause the video. Once you've paused the video, attempt the question, and when you're ready, press play and I'll go over the actual answer itself. So this is the question. The graph shows the variation in concentrations of reactants and products as a function of time for the following systems. We've got carbon oxide dichloride, which is a gas, goes into chlorine gas and carbon monoxide gas, and it's an endothermic reaction. Identify and explain each of the changes in conditions that have shaped the curves during the time the system was observed. And this is the graph. We've got concentration on this axis, and we've got time on this axis. We've got 3 different parts. We've got chlorine gas here, we've got carbon monoxide and carbon oxide dichloride here for the graph. And what you need to do is identify and explain each stage of the changes. But you get 5 seconds to pause the video and then attempt the question. And when you're ready, I'll go over the actual answer itself. Welcome back. Alright, for this question you should realize that obviously when it comes to Le Chatelier's principle, which is what we have to apply here, there were 3 main things which could disturb the equilibrium. There was pressure, temperature, and concentrations, change of concentrations. Change of concentrations. And if you notice the massive changes, there were 3 overall changes. One happened here, one happened here, and one happened here. And then obviously the equilibrium reacted. So you can already guess that there'll be both pressure, temperature, and change of concentrations in this actual graph. And you need to figure out where they actually happened and why they happened as well, because you need to identify it, which is to say just what happened at these stages, and then explain, so why did this happen. Right, the first, what I said initially, it was that at this stage of the graph, there was no change. Here, there was heat added to the system. I'm going to go over all of these steps in a second. Here, there was concentrations of carbon monoxide was put out, so carbon monoxide was removed at this stage. And here, the pressure was changed. Pressure was changed, and then the equilibrium reacted in every case. So I'll go through these steps. First, what I said is the reactants and products are in equilibrium from 0 to 4 seconds as the concentrations do not change. That's what I mentioned, this part here. We've got equilibrium, nothing is changing. Then the second part, which was here, when I said that heat was added, I said why as well. Obviously, I could conclude that from what happened. Heat was added to the equilibrium at 4 seconds, and the equilibrium shifts to right to use up the added heat. So that's the explanation. It uses up the added heat, thereby going to right. So the concentrations of products of the forward reaction increase, and the concentration of carbon oxide dichloride decreases. So because we're shifting to right, because we're actually going to right, because this is an endothermic reaction. So if we have added heat, if we have more heat, if we do this forward reaction, it will use up that heat. Right? And that means that we're going to have more chlorine and carbon monoxide being produced and less carbon oxide dichloride. And that's exactly what happens. So we can see this goes down, whereas the other 2, they go up. And you might think, why this could have also been pressure, and this could not have been pressure. And the reason why is because the concentrations didn't change. But we'll go over pressure in a second, and we'll go over pressure at the end. But this was definitely due to temperature change. In this case, heat added, not to pressure. Go for the next point. So then I said, so this was from 4 to 10 seconds. So here heat was removed, and then the equilibrium changed to accommodate that change. And then something else happened again at 10 seconds. So at this stage. And that was that carbon monoxide was removed. Some carbon monoxide was removed at 10 seconds, which disturbs the equilibrium and favors the forward reaction, so it favors this reaction. So it shifts to right. to produce more carbon monoxide. Concentrations of carbon monoxide rise after the initial drop. So you can see here it's dropped quite dramatically. That's because it was taken out. But then it starts increasing again. And so does chlorine gas. It also starts increasing. The concentrations of carbon monoxide rise after the initial drop, and so do the concentrations of chlorine, whilst the concentrations of carbon oxide dichloride further decrease as they are used up in the reaction. So because we want to produce more of this as this was taken out, it will shift to the right, and in doing so, obviously, this will break down to form chlorine gas and carbon monoxide, which is why they decrease and the other two increase. And that happens at 10 seconds. So we're almost done. So far we've had, equilibrium initially, then heat added, so then we forward the forward reaction because it's endothermic. Then at 10 seconds we have removed carbon monoxide, and that shifts the reaction further to the right to increase that carbon monoxide concentration again. And now the last step was the pressure. So what I wrote is the volume of the container is increased at 14 seconds. So that was this point here. And how did I know that? Well, which is evident by the initial drop in the concentrations of reactants and products. Remember, what was concentration? It's just how much is in any given area. So if this was the concentrations beforehand, let's say there's 5 in here. If we had just increased the size of the container, but we didn't change the amount of particles there would be in, then we would have, for the same space, there might only be 2 pieces here because the other pieces have gone somewhere else. So we've increased the size of the container as the concentrations for each part, so not just for one of them, but they're all dropped. So that's how we know that was pressure that we changed. Obviously, if we decrease the concentration, that means we've increased the volume, that means we've decreased the pressure. So, which is evident by the initial drop in concentrations of the reactants and products. This means there was an overall decrease in pressure because we've increased the volume. The equilibrium will shift to the right. So again, it will shift to right again, and in every case it will shift to right, to produce more molecules in an attempt to increase the pressure and counteract the change. Because if you remember, we said that if there was a change in pressure, it will try to counteract that change. In this case, we have more space, so it will break some of these into these, because here we have 1 molecule, and here we have 2 molecules. So this will take up more space, and that's what we have to do because we've increased the space. We want to have something that takes up more space. That's why, for last example, it also moved to the right. So again, this would have given you your full points. I'm sorry, actually, I didn't write how many marks this was worth. This was worth 5 marks. And you would have gotten your marks for just mentioning, obviously, identifying stages. So heat was added, and then explaining why. You would have done the same for these. And these ticks might only be worth half a mark in some cases. But overall, you would eventually get to your 5 marks. Right, so you should have always identified the stage and then explained the stage. Obviously, you may also mention that initially the reactants are at equilibrium. And where does this come from? This comes from this dot point. Identify. So name factors which can affect the equilibrium in irreversible reactions. And these were obviously the pressure, temperature, and change of concentrations. And there's also another dot point which says we need to be able to go into a bit more detail, which is why they ask you to explain each stage as well. But I hope that was useful.
Thank you for watching.